Billy, good evening.
Good evening, sir.
How are you doing?
I'm fine, and you?
Not bad, thank you. Billy, where are you phoning us from? Where do you stay?
In first state in the in a small city called the Tire.
Okay, I want you to read your question to me. Have you got your question with you?
Yes.
Okay, read it out to me.
I didn't give you all the question, but I just give you the constant ratio. The actual question says, for which values of x will the infinite geometric series x over 2x minus 1 plus x over 2x minus 1 squared plus x over 2x minus 1 cubed converge?
Okay, so for which values of x will this infinite geometric sequence converge? Am I right?
Yes, yes, sir.
Okay, Billy, to find out when something will converge, what does it mean to say that something converges, that a geometric sequence converge? What do I mean by that?
It has a sum to infinity.
It has to?
It has the sum to infinity.
Okay, okay. If a sequence does converge, it does have a sum to infinity. You're 100% correct there.
The constant ratio must be between -1 and 1.
That's what I wanted to hear, Billy. Well done. So for this to exist, our constant ratio, which we find by saying term 2 over term 1, that constant ratio must lie between 1 and -1. Perfect. Okay, what is your constant ratio here, Billy?
It's x over 2x minus 1.
Exactly, we can see that if we divide this term into that term, all it does is get rid of the power 2, and the same happens if term 3 is divided by term 2. Okay, Billy, so we know now that for this specific sequence, our constant ratio, which is x divided by 2x minus 1, must lie between 1 and -1. It cannot lie outside of those boundaries. Okay, now the sequence work is over. I'm going to hide the sequence for the meantime. Now this here is a grade 11 inequality. Can you see that?
Yes.
Okay, how do I solve this inequality, Billy? Do you have an idea?
No, I don't have an idea. I tried to multiply by 2x minus 1 in both sides, but I got stuck.
Okay, and that's exactly what you should not do. Okay. You cannot get rid of this denominator. That denominator, unfortunately, when you work with inequalities, it has to stay. So we're going to break the question up, Billy, into that first of all. We're going to first try and find out for which values of x will x over 2x minus 1 be smaller than 1. Then we're going to go and let me just get another color. Let me try this thin blue. Then we can use the second part and then find out for which values of x will x over 2x minus 1, I'm reading this direction, be bigger than -1. Okay, and this is an AND solution. It's not OR. Now that AND is very important, Billy. It must be smaller than 1, and at the same time, it must be bigger than -1. Because there's an AND here, it means I've got to combine my two answers once I've got an answer for each one of these inequalities, okay?
Okay.
Now, Billy, what you don't want to do is you cannot get rid of this denominator. You cannot get rid of it. Unfortunately, you have to keep it. Like you did with all the inequalities that you did in grade 11. Billy, are you in grade 12?
Yes, I'm in grade 12.
Okay, so I'm just reminding you what you learned in grade 11. You may not get rid of this denominator. And the reason for that is because you don't know whether it's positive or negative. Because if you multiply a negative number over this inequality, it's supposed to change its direction. You agree?
Okay.
Okay, so what are we going to do then? We are going to say, let us take these constant numbers and let's transpose them to the other side. So we're going to do the same on this side. It's going to come back and then we're going to be left with a 0 on the right-hand side of our inequation, okay?
Okay.
Okay, so what happens is this plus 1 becomes a minus 1, and that is smaller than 0. Now, let's just do one thing at a time. Let's solve this one first of all. This is a fraction, that's a number. To be able to do this, I need to add the fraction with the LCD. In this case, it's 2x minus 1. You agree?
Yeah.
Okay, so I've got x minus this, in a bracket, 2x minus 1, and that is smaller than 0. Okay, and the rest is just adding numbers together. I get x minus 2x. That gives me negative x. Then I get a minus times a minus is a plus 1. So that's what I'm left with at this point. That must be smaller than 0. Okay, now I don't like, and I don't think you like this as well. We don't like this negative that lies in front of the x. You agree?
Yeah.
Okay, so we make it positive by multiplying throughout with a negative. And if we do that, the second thing, exactly, that thing is going to change its direction. Good stuff. So we get x minus 1 over 2x minus 1 is then bigger than 0. You agree?
Yeah.
Okay, now I'm ready to solve. Now, a lot of you folks at home, depending on what method your teacher taught you, you're going to do it in that specific method. What I like to do, Billy, is I like to use my number line. Okay, so all I'm going to say now is say, okay, on a number line, there's a half and there's a 1. I'm looking at where things are positive, where it's bigger than 0. Now, if I were to fit a graph in here, it would come down. So I have a positive there, a negative here, a positive there. And it's always that it starts with a positive here because there is a positive in front of both these x's. I'm looking for positives. So my first answer here is x is bigger than 1, or here, x can be smaller than a half. You agree?
Yes.
Okay, so let's just highlight those. Those are the two answers that we got at so far. Now we go back and we look at the other half of the inequation, which is written over here. Okay, Billy, now you tell me what to do quickly.
We're going to transpose negative 1.
Okay, so it becomes everything over 2x minus 1. That minus becomes a positive, and I have 2x minus 1. You agree?
Yeah.
Okay, get rid of the brackets. Nothing is going to change. 2x plus x is 3x. That and that is minus 1. And then I get 2x minus 1, which is positive. Okay, now I'm ready for my number line. You agree?
Yeah.
Okay, let's go for it. A third is smaller than a half. So the third comes over here. The half goes there. There's positives in front of my x's, so it's positive, negative, positive. I'm looking at where things are bigger than 0. So here, this part tells me that x must be bigger than a half. Or, from the third to this side, x is smaller than 1/3. You agree?
Yes.
Okay, now let's see how that now influences what I've got here. There's my 4 answers that I now need to make sense of, Billy. And this is the step which you've got to use your imagination and draw a new timeline and put those values on that timeline. Because that is the part, Billy. Remember what I said in the beginning? I said this word "and" is very important. Remember?
Yes.
Okay, now that "and" tells us to combine your answers. Always. Okay, we're going to throw them together. So let's go and let's draw a final time, a line over here, number line. We've got the 1 position is a third. Then we have a half in each one of these. We've got a half, and then the last number is indeed 1. Now we fill in our solutions separately, Billy. And where those solutions are going to overlap, that's our final answer. You agree with that? Let's have a look. if x is smaller than a third, it runs this way. But then they said at the same time it must be bigger than a half. There. Here, for the second answer, I'm going to draw that in blue. X is bigger than 1, which lies over there. And then x is smaller than a half, comes this way. Now, Billy, if you look at this, the only place where these overlap is from here. There they overlap, and there they overlap.
Therefore, x must be less than a third.
Exactly. So x is smaller than a third, or x is bigger than the 1. So x cannot be anything between a third and 1, because for those x values, this will not converge. You following?
Yes.
Billy, how much was where did you get this question from, first of all?
On the textbook.
How much was it worth? Did they give you mark? Oh, they didn't give you marks there.
Yeah.
I would say this is worth round about 9 marks in an exam, because you're solving two separate inequalities. First of all, you need to interpret what converging means, and that you did quite well, Billy. Well done with that. Your constant ratio lies between 1 and -1. So for that statement, I'll already give you a mark. Then you split the one side smaller than 1, you solve it. There's good 4 or 5 marks there. And the other one was much shorter, so there's maybe 2 marks there, and in the combination, you will get 2 marks for your final answer. Billy, thank you so much for that, and then please phone us if you have another problem.